Okay, math students, welcome back. We are now on lesson 19, which is the fourth section of project 4. We've got 4 quick questions here, and we're still dealing with sequences and functions as related to crime. Okay, the following arithmetic sequence represents the number of hours spent in the crime lab based on the number of pieces of evidence collected from the crime scene. So the sequence goes 3, 5, 7, 9, 11, etc. If there is one piece of evidence, it takes 3 hours to analyze it in the lab. If there are 2 pieces of evidence, it takes 5 hours. If there are 3 pieces of evidence, it takes 7 hours, and so on. So our range here is 3, 5, 7, 9, 11. Now, because let's see, if we had 0 pieces of evidence, it would take 1 hour, which doesn't really make sense, but you'll see where this comes into play in a minute here. So this is an arithmetic sequence, which means we have a common difference, versus the geometric sequence, which we had a common ratio. So the common difference is just the difference between each of these numbers, and as you can see, that difference is 2. So we'll go ahead and just type 2 in here. And the common difference of an arithmetic sequence has the same value as the slope or the rate of change, okay? So what this means is that when we had 1 piece of evidence, it took 3 hours. When we had 2, it took 5, 3, 7, and so on. So our points were here. And our slope, remember, is rise over run. So our run is always 1. And our slope is 2 over 1, because our rise was always 1 and our slope, our rise is always 2 and our slope and our run is 1, rise over run. So rise of 2, run of 1, so our slope is 2, which is the same as the common difference. So that's a cool feature of arithmetic sequences. Okay, next question. Okay, so we know we've got that slope of 2, and we now want to know which function represents the rule for the sequence identified in question 1. Well, we can go ahead, we're going to just cancel out anything that doesn't have a slope of 2. So this is out, and this is out. That helps us narrow things down. Now, remember when I said that if we had 0 items, that it would take 1 hour. The reason that I said that is because if we graph this, okay, and I said one thing would take 3 hours, okay, and 2 things would take 5, 3 things would take 7, okay, so that puts us at these points, okay, but we still need to cross the x-axis, or the y-axis somewhere, and the place where this particular line would cross the y-axis is going to be at 1. And the way I can figure that out, okay, I know I have a slope of 2, so I've got y equals mx plus b, okay, and I know that m equals 2. And I have several values of x and y. Okay, so for example, I know that I have a point at 1 and 3. So I'm going to say 3 equals 2 times 1 plus b. 3 equals 2 plus b. So I can tell quite easily that b equals 1. So my initial value here has to be 1. All right, so y equals 2x plus 1, or in this case, we're doing a function of n. F of n is 2n plus 1. Okay? And the last question here. A suspect's distance from the scene of a crime in miles is given by the function f of x equals 75x plus 24, where x represents the time in hours that passes from the investigators, or from the time the investigators begin to track the suspect. Interpret the parameters of the function. What do each of the numbers 75 and 24 represent within the context of this situation? Okay, so the parameters of this function are that since x is time, x can only be positive real numbers. So let's go ahead and write that first. Because x represents time, x can only be positive real numbers. Okay, 75 is the speed or rate that the suspect is traveling away from the scene. Okay, that's the slope of our line, so it's our rate of change. 24 has to be the distance the criminal was away from the scene when the investigators began their tracking. So it's the initial distance. The crime happened, the criminal started escaping before the investigators started tracking them, and once the investigators started tracking them, the criminal was already 24 miles away. Okay, so that's what you need to write there. Hopefully that all makes sense, and I'll see you back for our last lesson, lesson 20 of Project 4. Thanks.